about solution of a recurrence relation, particularly linear in nature. In this lecture, we are going to discuss what are the different methods that are there for solving a linear recurrence relation, and also we are going to discuss one of those methods. A linear recurrence relation can be solved in three ways. The first one is method of substitution or method of iteration. The second one is method of characteristic groups, and the third one is method of generating functions. In this lecture, we are going to discuss method of substitution or method of iteration for solving a linear recurrence relation. For the sake of simplicity, we consider a linear recurrence relation whose order is eventually 1, and let us consider that the general form of the recurrence relation is an is equal to some constant c into an minus 1 plus some function fn, where n is greater than 1. Obviously, at the time of solving a linear recurrence relation by method of substitution, we need to have the initial condition given. Let us assume that the initial condition for the recurrence relation is a0 is equal to some constant k. Now, how do we solve a linear recurrence relation by method of substitution? In order to solve a linear recurrence relation by method of substitution, what we do is we try to substitute an minus 1 in terms of its previous term an minus 2. Then we try to substitute an minus 2 by using its previous term, that is an minus 3. Then we try to substitute an minus 3 in terms of its previous term, that is an minus 4, and we try to continue this procedure of substitution until we get an explicit form. Now, it can easily be observed that an minus 1 for the given recurrence relation is an minus 1 for the given recurrence relation is c into an minus 2 plus f of n minus 1. How do we get this? In order to get this, we put n equal to n minus 1 in the given recurrence relation. Now, if we substitute an minus 1 with c into an minus 2 plus f of n minus 1, then it gives us c square times an minus 2 plus c into f of n minus 1 plus f of n. Now again, we try to substitute this an minus 2 with its previous term, that is an minus 3, and to do so we try to find the value of an minus 2 from the given recurrence relation. To do so, if we put n equal to n minus 2 in the given recurrence relation, then this n becomes n minus 2, this n minus 1 becomes n minus 3, and function of n becomes f of n minus 2. So let me write this. From the given recurrence relation, we get an minus 2 is equal to c into an minus 3 plus f of n minus 2. Now, if we replace this in place of an minus 2, again we get c cube times an minus 3 plus c square into f of n minus 2 plus c into f of n minus 1 plus f of n. Now, just by observing the similarity, if we try to expand this substitution so that we get an minus k, if we try to expand this for an minus k, we get c to the power k times an minus k plus c to the power k minus 1 into f of n minus k minus 1 so on up to f of n, right? Let me show you the substituted version. After substitution, we get c to the power k times a n minus k plus c to the power k minus 1 times f of n minus k minus 1, which will actually give us f of n minus k plus 1 plus up to f of n. Now, our objective will be to get the initial condition in place of this a n minus k. Now, just let us assume that the initial condition is a0 equal to k. If it is so, then we are supposed to make this a n minus k to be a0, and to do so, we have to equalize n minus k with 0. From this we get k equal to n. Now if we replace, or if we put k equal to n in the right hand side of this equation, then this a n minus k actually becomes a0, and the other terms becomes c to the power n minus 1 times f of 1 plus maybe c to the power n minus 2 into f of 2 up to some function of n. Now, if this a0 is replaced by its explicit value, that is k, then the right hand side becomes a n-less or sequential termless expression, and from that we can say that after substitution of the value of the initial condition, this becomes the solution of the given recurrence relation, which is nothing but an explicit formula for finding the value of an. In the next lecture, we are going to demonstrate this procedure by the help of an example. So, thank you for watching this one. We'll see you in the next one.